Good afternoon, everybody. My name's Alex Yard. I recently joined E1 Marine, and I'm going to be spearheading the container project, as Robert had initially said. My background is in the oil and gas business, that dirty, horrible business, and I ran a number of vessels in that business in Asia. I sold my business a number of years ago, and I've been lucky enough to join E1 Marine, and I think I'm redeeming my sins for my time in the oil and gas business. I'm going to be talking about the container. A lot of the things I'm going to be speaking about is reinforcing what Dave and Robert has said already, and also what Dave Lee from ABB has said. Why are we going into the container business? Well, as been mentioned, and you've seen the picture many times before today, we're developing the Hydrogen One. And through that, we're learning a lot of industry-first knowledge. And this is easily transferable into the container business. You know, we've combined the reformer, which Robert has spoken about, and fuel cell in the Hydrogen One, and it's in a working environment and in a marine environment. And what we're going to be doing is putting that into a container system. We also see a great demand for clean modular power on the dock side. As we all know that the regulations are changing and vessels are going to have to use shore power. And the infrastructure is not there to always be able to support that. Big ports around the United States, they're investing lots of money into putting shore power for the big container liners, for the cruise ships, but still the vessels, the smaller vessels, the harbor craft, the ferries, they still need to be supported with shore power. And this is where we see we have a part to play. We're going to be, as Robert has mentioned before, our containers is going to use the same feedstock, methanol feedstock, mixed with water, and using with a fuel cell. So this is the production unit that we're developing at the moment. It's a 300 kilowatt unit, and we believe that we've done some estimations, and we believe that we can provide energy at a lower kilowatt rate per hour than similar units using bulk hydrogen. And I think through today's discussion, we've seen from Dave all the disadvantages of using bulk hydrogen. And we don't need that because we are producing hydrogen at the point of demand. We see a number of uses around the waterside and afloat. Of course, to produce shore power, the unit itself is ideally adapted to the lower voltage vessels, the smaller vessels. As I said, the large vessels, the container vessels, the cruise vessels, they are high voltage, and usually it's economical for the ports to put in infrastructure to support them. But for the lower voltage vessels, you know, they don't have the infrastructure, and we see this as a prime solution. It also can be used for charging dockside equipment and, of course, charging e-vessels. So what are some of the advantages? Of course, it's been mentioned previously, the emissions, no NOx, no SOx, no particulate matter. And it's, you know, because it's portable and it's scalable, we can combine multiple units together to get larger power outputs. It's ideal for ports that don't want to spend a lot of money to put in infrastructure into remote areas of the port. It's low noise and it's low vibration, means it has a low maintenance cost profile, which is good for any operators. And let's move on. And where do we see it being used? Of course, I mentioned before shore power. And we see a big market for this container to be used in the reefer market, powering reefers, which right now is being supplied by diesel generators if the grid power is not available. We see it being used on floating power barges, where vessels are double stacked or anchored in the harbor. They still have to meet the regulations imposed by the ports and the states. And they still need to either turn off their auxiliary power engines, and they need to have shore power. So if it's not convenient to run cables over a number of vessels, a floating power barge would be ideal. Afloat, we see that in the future, our units can be used much the same way as the diesel gen sets are used right at the moment, but as a much cleaner option. So let's talk about the passenger vessel market. Of course, we're going to be encouraging any owners to consider fuel cell as the main power source, and that combined with our reforming technology. But we also see our container being used as a charging station for battery vessels, for shore power or on conventional vessels, or range extenders on hybrid type vessels. We think they're well suited for areas that don't have the infrastructure. As you can see down at the bottom, this idyllic location, they probably don't have any infrastructure running to it. And we'd love to put one of our containers in that kind of place, and the E1 team would be happy to go down there and do a site visit.
Welcome anytime.
Thank you. I know where that is. So for battery ferry, now we understand that for many operators, point-to-point, fixed schedule type operations, they don't want to spend too much time alongside, and we need high-speed charging. So we see our container solution being used with a high-capacity energy source, in effect batteries. And this could be put alongside our container and hopefully charge the batteries in really short amount of time. And while the ferry is away, our container would recharge the battery pack on the shore. The charging of the ferries can be done either through inductive charging, which is now being introduced, or traditionally through cables right there on the dockside. The container, the M2H2 power container is just part of the solution. Hopefully it will be coming into the marketplace by midway through next year, maybe Q3 next year, and we hope it can find solutions for many of your operators. Thank you very much.